Random. It is such an old topic to talk about, but it's very important nonetheless in our society. Random, by definition, is a lacking of a definite plan, purpose, or pattern. Now, you all might wonder, we all might wonder, is random a real thing? Or is it just fake? Now, to answer this question, the short answer is no. By a definition of the word random in this context, it means that in terms of cause and effect, an effect must occur without any cause. In a deterministic universe, this is impossible. Now, we might ask ourselves this: is anything truly random? Now, that is an interesting question with particular importance, as randomness is a surprisingly useful tool in our society, whether it be on research, politics, or just our daily lives. Following no laws, random number lacks any predictability. So, when added to text, they garble it in a way that no one can unscramble without knowing that numbers were added to encrypt them. Randomness is also useful in simulating the effects of chance on complex systems, like, for example, the stock market, and for select representative samples of patients when testing new drugs. Researchers typically use random numbers supplied by a computer, but these are generated by mathematical formulas, and so, by definition, cannot be truly random. In the 1970s, scientists discovered that a widely used formula produced regularities in its random numbers that undermine countless research studies, which is quite sad because the studies are now gonna be ruined by it. Now, true randomness can be generated by exploiting the inherent uncertainty of the subatomic world. And to explain what a subatomic world is, subatomic world is a world inside an atom or smaller than an atom, which is unexplored and uncertain. Now, let's move on to a more fun and interesting concept or study of random, which is quite a load of fields. But now we're only going to talk about scientific definitions for random. Now, random, or pronounced random, relating to a type of circumstance or event that is described by a probability distribution. Now, we don't talk about probability distribution now because it is an entirely different topic. Now, moving on, relating to an event in which all outcomes are equally likely, as in the testing of a blood sample for the presence of a substance. And that is but one of many examples of scientific randomness. Now, we're also gonna learn and try to understand what is random variables and their distributions, which is quite an important topic. So, you guys got to listen carefully. Now, what is now what exactly are random variables? Now, a random variable, also known as stochastic variable, is a real valued function, which is quite important. So listen well. Whose domain is the entire sample space of an experiment. Think of the domain as the set of all possible values that can go into a function. Now listen well. This is a very important function, so we all have to learn. Now, this important function is a function that takes the domain slash input, processes it, and renders an output slash range. Similarly, a random variable takes its domain, which is sample space of an experiment, processes it, and assigns every event and outcome a real value. Now, this set of important real values obtained from the random variable is called its range. In statistical notations, a random variable is generally represented by a capital letter, and its realizations, observed values, are represented by small letters. So there's a difference between the capital letter and the small letter that is used in random variables. Now, considering the experiment of tossing two coins, we all do that at some point in our lives. We can define x to be a random variable that measures the number of heads observed in the experiment. Now, for the experiment, the sample space is shown below, which is S equals to H and H, H and T, T and H, T and T. You can see it in the video. Now, there are 4 possible outcomes for the experiment. And this is the domain of x with a capital. Now, the random variable, which is x, takes these four outcomes slash events and processes them to give different real values. For each outcome, the associated value is shown as x HH is 2 heads, XHT is 1 head, XTH is 1 head, XTT is 0 heads. Thus, we can represent x as follows. X is S, which is sample space, turns into or processes into R, which is a set of real numbers. Now, we are going to talk about types of random variables. Now, there are 3 types of random variables: discrete random variables, continuous random variables, and mixed random variables. Now, discrete random variables are random variables whose range is a countable set. Now, a countable set can be either a finite set or a countably infinite set. For instance, if in the above example, x is a discrete variable as its range is a finite set, which is 1, 0, 1, and 2. Now, for continuous random variables, on the contrary, have a range in the forms of some interval, bounded or unbounded, of the real line. Now, example. Let y be a random variable that is equal to the height of different people in a given population set. Since the people can have different measurements of height, not limited to just natural numbers or any countable set, y is a continuous variable. In fact, the distribution of y follows a normal quotient distribution on most occasions. Now, there's mixed random variables. Lastly, mixed random variables are the ones that are a mixture of both continuous and discrete variables. These variables are more complicated than the other two, hence they are explained at the end of this article. Now, for the example, the monthly sales of a certain product are believed to follow the given probability distribution. Suppose the company has a fixed monthly production cost of $8,000 and that each item that brings $2. Now find the expected monthly profit, which is H, from product sales. Now the number of items, there's 5,000, 6,000, 7,000, 8,000, 9,000. And there's P, 0.2, 0.3, 0.2, 0.2, 0.1, which is equally 1. And then there's XP, which is 1,000, 1,800, 1,000, 1,600, and 900, which is 6,700. Now the expected value of a linear function of a random variable is e ax plus b equals to ae x plus b. In this case, e 2x minus 8,000, which is 2e(x minus 8,000) equals to 2 multiply by 6,700 minus 8,000, and the answer is 5,400. And unfortunately, this is the end of our video. Thank you for listening. Goodbye.